All right, so we're gonna kick off this. You guys ready, Yoav and Matt?
Yep.
Awesome. Okay, so welcome to another episode of CTO Corner Series. We're very excited to have, as usual, Yoav Landman, our CTO and founder of JFrog. How are you doing, Yoav?
Doing great. Hey, Steve.
Cool. Thanks for joining us. I know it's late there as well, so you get to do it this evening time, your time. And we also have Matt Moore, who's the founder and CTO at Chainguard. So or CEO of Chainguard. How are you doing, Matt?
CTO. I'm doing great. Thanks for having me.
Cool. Okay, so we have a proper CTO corner with two CTOs in the room. That's awesome. And what we wanted to talk a bit about today is supply chain security. Why this matters today. It's trending a lot. It's the talk of not only security specialists but also developers, and then get into like some of the ways which we're trying to mitigate risk for large enterprises or address this problem for the ecosystem. So I guess just to kind of kick things off, why now? Like, why is supply chain security such an issue at present?
Matt, you want to start?
Sure, I'll start. I think that one of the things that makes this such a sort of hot button issue right now is a mix of both the volume of attacks that we're seeing as well as how high profile some of them are, right? A couple of years ago, I hadn't heard of SolarWinds, and now these days that brand has become sort of synonymous with one of the highest profile attacks we've seen in modern history, right? Where as national news, folks were testifying in front of Congress, right? And so and that was really just one of many of these attacks that have been happening, and we've been seeing a pretty steep curve of growth. I think I just saw a figure that it increased something like 650% last year in volume, and I think we should expect to see that probably for the next few years, the way things have been trending, until we can sort of start to get some realistic safeguards in place to help folks start to combat these kinds of things.
Yeah, I share the same numbers. Also just the fact that this 99% of every enterprise's software is made up of open source. So I think that there's been a shift in the how evil forces are operating. Before it was just viruses. So in order to get a virus, there were two ways, right? Either they would attack you directly, like try to penetrate your organization firewall through various means and try to make their way into the organization network. And through software, it usually was viruses, and the attackers were trying to lure you to download viruses through freeware or things like that. And now you don't need that, because with the explosion of software and the fact that open source is so common, the easiest way to get in is through the supply chain. So the easiest way to get yourself in is to bake yourself in a smart way into the binary, whether you compromise the process or whether you manage to slide in some rogue artifact that ends up as part of your bundled software. And the last force, I think, it's cryptocurrency. I think it made it a lot easier for people to steal without getting caught. You don't have to wire your winnings to a bank account that's identifiable. You can just stay anonymous and get the gains.
Yeah, crypto has definitely made it easier to get paid for these kinds of things, which has made it much more appealing as a target.
Yeah. So you mentioned the SolarWinds attack, Matt, and I think that was a super high profile exploit. It kind of showed the potential for the damage that you can produce by these sort of attacks, but maybe it was a little bit isolated in the sense you had to be a customer of SolarWinds or you had to be in that specific space. But when I think you look at things like the Log4j incident or Log4Shell, which happened earlier this year, that kind of brought it to everyone's attention that it's not just certain organizations which are being targeted, like the whole world is vulnerable. So when you look at security exposures like Log4Shell and other open source vulnerabilities, how should companies respond to this? Like how do you realistically respond to threats coming from all angles?
Well, I mean, I think it's hard to give a one size fits all answer. But I think, you know, you really need to have the best possible information you can. And I think signal to noise is something that we really struggle with as an industry. And so knowing, you know, a new vulnerability comes out and there's sort of the set of places that, you know, my SCA tooling says are vulnerable, right? Realistically, where am I exposed? Where am I using those things? You know, a few years ago, Dan, our CEO, and I started a project called DistroList that was looking at trying to actually reduce the size of sort of runtime images, specifically to look at these kinds of things, because folks starting from full-on distros, right, to build images, right, you have a lot of stuff in there that your actual image at runtime doesn't need to do what it does, right? Like, is your web service installing things with dpackage and, you know, doing things like that? Probably not. You know, sure someone is, but I would say the vast majority of folks aren't using a lot of those tools, right? Those tools exist to sort of bootstrap your image, but at runtime, you don't need a lot of those things. And the analogy I like to make for the Java developers of the world is, you know, it's sort of like the JRE versus the JDK, right? JDK is great for developers. It has a lot of really good tooling for sort of building things up, but at runtime, right, you don't want, you know, your Java compiler and all this other stuff in, you know, your runtime container, right? You really want that sort of curated runtime environment for those kinds of things. And so that's the spirit of DistroList. And it's one of the ways, right, like you try and improve that signal, right? But the importance of signal, right, is ultimately in reducing the set of things that pop up on the radar when one of these new vulnerabilities lands, and that you have to go and get patched and rolled out, right? And overall, your organization's sort of mean time to remediation is sort of a function of how many things you need to go and, you know, get updated. And so the more you can sort of zero in on exactly the set of things that are actually affected, I think the better off you're going to be. And so I think that's one of the sort of guiding principles that I think is as close to a one-size-fits-all answer as I can give. But yeah, knowing your exposure.
I think that's really good. And getting to your second point about like zeroing in and honing in on like exactly where your vulnerabilities are. How do you see this happening in large enterprises, Yoav?
Yeah, so the thing with the Log4j, I think what made so much noise around it is the fact that it's a 0-day. It's not a regular vulnerability that you discover. It was brought to the market out of the blue, ruining a lot of weekends and nights for a lot of good people. And just by the fact that Log4j is so incredibly popular, the impact was like critical. And then it becomes a game. It always reminds me that the car industry, when you have a recall on a car, you know, and this like it's a car that can potentially lose the brakes. This is the amount of risk that you get exposed to with Log4j. So you have to fix it immediately because you have a remote code execution that is that could be up there in your running applications. So it becomes a game of identifying what needs to be recalled, and also a game of blocking. So what we had customers like huge enterprises that have tens of thousands of applications running Log4j, and they had to first identify those applications, and then they have the system of record and the SBOMs in Artifactory in X-Ray that tells them where Log4j is included. But they also have to make sure that they rebuild them with the patched version of Log4j as the immediate, this is what the biggest ones did. They really patched Log4j. They kind of pulled out the bad classes that they know they're not using. It's just a crazy feature that allows you to pull code through LDAP. I don't know who invented this crazy dynamicity, but apparently someone thought it's a good way to dynamically change the log settings. Anyway, they had to pull out this bad code, patch it in Artifactory to make sure that when they rebuild, they build with this augmented version, and also block it all together, and of course also identify what they need to rebuild. So this is this was the game plan for them.
Yeah, it's one of those. I think it's probably the worst vulnerability in modern history that I've seen. Right, so you know, there's this class of vulnerability that, you know, you talk about these black swan vulnerabilities. There used to be this. Well, I don't have access to it anymore, but there used to be this sort of document at Google talking about these black swan vulnerabilities, where you sort of to position the severity of these kinds of things, right? Imagine vulnerabilities so bad you would take down something like google.com to avoid, you know, the damage that could be incurred by one of these vulnerabilities, right? And that I think Google actually skated by relatively unscathed by Log4j, but I think that for many organizations, right, Log4j was very much that class of vulnerability, right? It's like, you know, you send a payload to a random HTTP request. In some cases, you just stick the little thing in headers, right? It gets logged and it pings you and it tells you they're vulnerable. And you now have, you know, a catalog of services where you know exactly where you can plug in and attack these folks. And so I think there's a lot of things about, you know, I'm most familiar with sort of some of Google's security postures around these kinds of things that I think helped to sort of insulate and mitigate them, even if they were running aspects of Log4j. Like, for instance, you know, default denial, zero trust networking is a great practice, because being able to phone home is a great way to let attackers let you know that you are vulnerable to these kinds of things, right? And so you know, doing things like locking some of those things down, and, you know, there's a whole bunch of practices that I think help to mitigate. And really, as pervasive as this thing was, right, you know, if the easy thing, you know, hackers like to find the easy way in, right? And if the name of the game really isn't making it impossible, it's making it just prohibitively difficult, right? Because at some point, if they really, really, really want to go after you, and it's, you know, a nation state actor, at some point they will get in, right? And so you want to make that as hard as possible, and you want to make it so that you have the tools to sort of audit and assess what happened, you know, if and when that happens, right? And I think that's one of the things, you know, with supply chain is like, open source is such a huge part of what folks ship in modern applications that it's a really target-rich environment for supply chain attacks. And if one project makes it exceptionally difficult, folks won't go after it, right? They'll go after one of the other, you know, dozens of projects folks are using. And so ultimately, right, like, I think we need to make it very difficult to go after open source projects in general and try and improve this really industry-wide, which is why projects like Sigstore putting so much effort into things like the public good instances, and trying to make it so easy to use some of these things with the tooling that folks in the ecosystems are using. But yeah, making it as difficult as possible to really get those footholds and you know, be the yeah, what's the saying? You don't need to outrun the bear, you need to outrun the person behind you, right? And so, you know, making it so that, you know, you are not the easiest target in folks' supply chains, I think is, it's a low bar, but, you know, you want to, there is invariably going to be a customer where you may be the weakest link with respect to the supply chain. And so improving your practices so that, you know, they're as strong as possible is definitely where you want to be.
So I think, and maybe Sigstore can also help in that regard, but I think it's one thing to kind of verify the identity of the artifact and like the provenance of it, including the whole chain. And there's also this added metadata that I'm not really sure how it plays along, but this added metadata is divided into the naive world of the CVEs. You know, you have a vulnerability because you wrote your code in a way that is not secure enough, and there are a lot of practices and scanners. But there are also vulnerabilities, like you mentioned, Google being proactive about it with the networking policy. JFrog is doing something similar with scanners that are actively looking for malicious packages. So for things that can get into execution from the network or other proprietary signals in code. And we managed to actually find hundreds of malicious packages that are trying to steal your credit cards from Chrome or get to the registry and do some malicious stuff in order to get control over your assets. And at the end of the day, you also want to add this type of information to the identity of a package, of a software version. So I'm not sure how that all can play along together, and what will happen in the market in terms of standardization. There's a lot of efforts right now that are trying to augment this type of data and to make it shareable.
Yeah, so I think both you and Matt are kind of headed in a similar direction. So like there's certain things you can do to secure your corporate environment, but ultimately those rely upon the things you depend upon, the open source libraries, the dependencies upstream, having the right level of security on their own project, and knowing that you're getting the right the binaries and packages from upstream projects which have been security scanned and are safe to use. And what activities are happening upstream to support open source projects and to make open source projects, especially the more popular ones and widely used ones, more secure for end users?
So I can talk to a few things on the Sigstore side. So you know, one of the things, as you have mentioned, that Sigstore is doing is there's this sort of new style of signing that's identity based, and it's what we call keyless. And I think it's one of the things that factors into this for a few reasons. But the keyless signing, I think historically one of the challenges getting folks to you know, do signing is that managing those keys is hard, and you know, there's a fair amount of risk for, you know, leaked signing keys, right? So if your signing keys get leaked, you know, folks' ability to verify the authenticity of the artifacts you're producing is, you know, then compromised, right? So with keyless signing, it's a lot like the aim, the sort of the way we try and describe it, so folks, you know, have some sense of a familiarity, right? Is trying to do for signing sort of what Let's Encrypt did for TLS, right? Try and make it really easy to get signing keys and sign artifacts using a sort of challenge process, so that it's approachable by folks and they don't have to deal with, you know, old school sort of draconian key management problems as you would have with traditional mechanisms. So basically what the way this works is you, if you were able to produce an identity token, so an OIDC token, and OIDC, I'm such a fan of OIDC and what it's doing for auth and Z across different providers, but the identity challenge is built around this. And so a lot of CI/CD systems are launching support for identity tokens, like GitHub Actions is a great one that last fall launched support for producing identity tokens. You can use this identity token to go through this identity challenge with the keyless signing stuff in Sigstore and sign your artifacts. And what it does is it produces a signing key in memory. It then talks to the public good instance through this identity challenge, and the public good instance effectively signs it into a certificate chain. And so you can verify against the root certificate to, you know, verify the authenticity of these things. And then when you're done signing the things with that key, you throw away the signing key and it's never written to disk. It's, you know, it's gone, right? So you can't sign more things with it. And that certificate chain metadata includes things like the identity that, you know, was performing the signing. So if I were to sign something in GitHub Actions, it would include things like the name of the workflow that, you know, that identity token was for. And so now I can take those signatures and I can couple them with policy, right? So when I'm deploying things to, you know, production, I can say, well, I only want things that have to go into production that have been signed by, you know, my company's release automation, you know, and these are the identities that those things run as. And you can now get that verification, and none of your CI/CD processes at any point we're handling a long-lived credential or signing key, right? And so I see it very much as a symmetrical argument to, you know, I think folks are starting to accept more and more this production best practice of don't use long-lived credentials, use short-lived credentials, right? And I think one of the things we're seeing with supply chain is you need to treat your build system more like a production system. And so what this enables is for you to actually have CI/CD workflows that aren't dealing with long-lived auth anymore, right? It's dealing with these short-lived identity tokens, and you're still able to do things like, you're now able to do things like signing and whatnot very, 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 very easily. And so I think making it approachable by projects so that they can just do those things very, very easily without needing to toil about how they manage keys and you know, deal with revocation if there's leaks or whatnot, right, is I think a really big aspect of that. So
yeah, no, I think
funny,
that's
we
Go
did
ahead,
the
Yoav.
same thing in JFrog pipelines. We probably should have used Sigstores had we known that it's happening at the time. But we're doing something very similar. We're creating a keeper at the very start of a pipeline, and then we use a transparency log to sign every action, like the actual JSON input and output of every action that happens in the course of the build. And when the build finishes, we throw away the private key and we keep just the public key. And that allows us also to verify the outcomes of different builds. So for instance, if I have build A creating a Docker image and somebody somehow gets into the tag and overrides it with some other checksum, the other build that gets triggered because of the creation of the Docker image, it will fail. It will tell you that it cannot look up in the transparency log. It couldn't find out a proof of evidence that this image is from the upstream build. So it's kind of nice. The other activity, by the way, that JFrog is part of is as part of the OpenSSF, securing public repositories. So we are there because of Conan Center, which is an open source project that JFrog is sponsoring for package management for C and C++. And the talks are there also about adding Sigstore to Conan Center and using cosign to sign Conan packages.
Yeah, I think one of the things that has exceeded my expectations is how many of the packaging ecosystems have like come to Sigstore and been like, we want to integrate this. I mean, I think there's a group of at least 4 or 5 that I know of. Conan, I actually hadn't heard that y'all are engaging with Sigstore, but there's a group. So a group of folks from Shopify have been pushing within the Ruby ecosystem, and they've been actually helping to lead the charge on this working group. But I know some folks within the Maven ecosystem are looking at this, the Node ecosystem, the Python ecosystem. It's just been pretty crazy how many of them have sort of come to Sigstore to engage on this and how they start to incorporate this metadata. So I think that's one of the interesting things that a lot of folks, it's one of the easy misconceptions to have about Sigstore, which is that it's just about container images, which is, you know, I think that's one of our biases with sort of where we started, just because they're so pervasive, and really that in many cases has become the sort of canonical handoff to a lot of production systems, which is one of the key places you want to guard. But there's a lot of sort of intermediate binary artifacts that you need to sort of secure along the way. And so it's great to see a lot of those starting to get a similar level of attention, and to see the amount of sort of collaboration that's happening across those contexts. It's very, very exciting.
I think the best collaboration will happen once the clients adopt the library to automatically verify it for you, because you don't want to trust the user. It's like the same way that security in the web became a real thing once browsers started to enforce the standards.
Yeah, absolutely.
Okay, so speaking of kind of like we've talked a bit about how you get more transparency into like who's signing or the certification process of the open source artifacts. I think one of the things which came out of the SolarWinds incident was a big push towards having software bill of materials, which give you the traceability, allow you to show exactly what the composition is of your software. So how does this all play into kind of giving that record to your customers or your operations teams or other folks about what's actually in your production deployments?
I can start. I think JFrog was really pioneering software bill of material without calling it this way. We started with BuildInfo, which today also has an open source site, buildinfo.org, in which we really capture the actual set of dependencies that are part of your actual build. And then you can, of course, export to SPDX or CycloneDX or the other more standardized formats that came out later. But we also capture evidence as part of the pipelines, like I mentioned before, those JSONs that I was referring to, we refer to them as pipe info. And then we have this notion of an application, which we call a release info, which is just a bundle of files. So there are plenty of document that describes different parts of the software supply chain. I know that maybe Matthew will want to speak about it. I know that Salsa has some evidences that are integrated with Intoto and with GitHub Actions, but I don't think there's a real standard today to capture all those evidence, except for the SPDX and the CycloneDX for the dependent artifacts themselves.
Yes, I think there's a few parts, right? So software bill of materials is absolutely one of them, and it's been great to see, the standards starting to emerge there. Even if we can't reconcile SPDX versus CycloneDX, getting down to 2 is actually a great place to be for SCA tooling for sure, right? Because, I remember writing vulnerability scanners where you're like, okay, what distro am I on? Crack open the package manager database for APK, or, the Berkeley database for RPMs, or, the thing for DEBs, it becomes this, very high arity exercise. And we haven't even talked about language manager package databases, right? So getting it into that canonical form, I think, is extremely valuable, right? And so even if you're just taking the binary artifact and, normalizing things into that SBOM form, I think that's very, very, very valuable, right? I think the levels beyond that are sort of not necessarily taking at face value what the image says is in there, and having those SBOMs produced by sort of a trusted layer of your build system, right? So you actually observe the set of things going in, and the SBOMs produced by a layer that isn't necessarily executing untrusted user code or elements of your dependencies. Some languages are better than others here, but everyone likes to point at things like NPM, where it's like, okay, I'll download something off the internet and run it. And, in those contexts, you don't necessarily want your SBOMs to be produced by the same processes that are doing that. And so I think and what goes into them is also just one aspect of it. I think one of the things that SVOM may start to capture some of this stuff over time, but it's one of the things that within Salsa is referred to as the Salsa provenance. So if you think of SVOM as sort of, at least today, or as the sort of ingredient list, I think of Salsa provenance as the sort of the recipe, right? How you combine those ingredients and you know, what processes are sort of handling those ingredients and in what ways in order to produce, you know, the output, right? And so I think Scott did Scott, one of my co-founders, did a presentation. I think this may have gotten turned into a blog post where he talks about like producing blueberry muffins, right? So there's a set of ingredients that go into that. There's a set of things that handle those things in terms of transport, you know, picking the blueberries, you know, and the machinery that produces the blueberries, the packaging, and then ultimately shipping blueberry muffin to users, right? So being able to trace back a bad ingredient or, you know, a contaminated piece of tooling, you know, in the food metaphor, I think is an interesting way of thinking about it. Today, I think SVOMs really capture the ingredient list, sort of reflected in the name, bill of materials, right? But I think starting to capture aspects of what tools handled it along the way is another really important aspect of it, right? Because say I didn't wash my hands, but while I was cooking the blueberry muffins, and you know that may have contaminated the process, and if folks start to get sick, it would be good to, you know, identify me as the common element there and recall the set of things that, you know, that I produced on that day. So so salsa provenance, I think, is one of the really you know, interesting things. You know, it's not as far along or being pushed as heavily as a standard yet, but there is some discussion happening there, and I think they're on at least their second iteration of the schema for that attestation. But yeah, seeing more and more standardization around how we describe those kinds of things, I think will I think they're sort of like an API, right? So APIs enable you to write common tooling against that standard API mechanism, like the container registry API, or you know the API for producing and consuming jars within the Java ecosystem, right? The more we can standardize around these common schemas for the set of things that go into these artifacts, or the set of things that handle the artifacts, et cetera, I think the more powerful tooling that will emerge to like tell you things based on that standard metadata. And so it's really exciting to see some of that standardization start to happen, because like I said before, you had to juggle, you know, a dozen different, you know, parsing a dozen different formats just to get a sense of what was in sort of a modern application.
Yeah. I kind of a little bit of a misbeliever in the ability to capture a process in a fully meta way. You know, it's so meta, then to generalize around it, I think it would be very, very hard, or even to build a tool that could display the information in a way that's comprehensible. So I kind of I think it can even be left open as long as the different tools that need to verify, they know what they're looking for to verify. For the static model, it's a lot easier. And here I think I actually hear it from customers that it's not just about the open source. Like we're living in your example about the ingredients, like the label you have on food, is exactly right. People want to know what they're consuming, what it's made of. So I think it will eventually, and not in the far future, go to commercial off-the-shelf software as well. It cannot sustain like that you just have to trust the vendor. It has to be exactly like the food industry, and I believe the risk is so high today that it's just a matter of time. I mean, once governments get their feet into it, and you start with those kind of conspiracy theories of whether Log4j is coming from, it was always there, but not just now we blocked it, but it was used heavily before, and what other tools governments have in the arsenal to go to a nationwide risk posing. This is going to drive a lot of effort in the industry.
I absolutely agree. I mean, I think that if the government, I think that what's missing is really effectively the reference architecture, really a vendor neutral reference architecture, although even these are starting to emerge. The folks from Citi helped lead an effort around this sort of secure software factory. It might have gotten renamed, but at one point it was called that, sort of reference architecture for producing some of this stuff. I think that as these things start to emerge, it will become more of a requirement, right? I think it's hard for governments to require it when, they don't have something they can point at to be like, just do it this way, right? And so I think you're exactly right. It's not an if, it's a when, and I think that when's coming to, various levels of compliance and whatnot in the not too distant future.
Cool. So I think this has been like a great discussion, kind of looking at the overall scope of where the open source security risks are, efforts being put on to improve the process, and then what were the tools we can use as companies to help protect ourselves. And just to kind of bring it back to more practical things, I think this is a good chance to both take questions from the audience, talk about practical things that developers or DevOps engineers can use to improve the security of their pipeline. And one of the attendees, Owusu Taki, asked what you can use to check or scan software at the entry point into your ecosystem, like right when it's downloaded onto laptop. So what tools or what technologies can developers and companies take advantage of to scan at the entry point to their environment?
Probably one of the easiest thing is to have, and this is like a company play, right? It's just to have a single source of entry, exactly like you have a firewall in a company. So once you have a software repository as part of the assets of your company, that's not just it doesn't only scan the artifacts and allow you to filter artifacts if they have vulnerabilities or even if you found 0 days on them. It's a great time saver for a company to just download everything from one central place and not waste the bandwidth of everyone. But usually this is the best approach. So you create a software repository. Obviously, in JFrog, our clients are using Artifactory to promote artifacts once they are being vouched by X-Ray and they are kosher, so to speak. And then you have like a safe place to consume your artifacts from, and it's always a temporal situation, right? It's safe today, Log4j. Next week it's not safe, so you have to keep monitoring. And this is this combination of a repository manager that hosts your artifacts with a scanning tool that keeps monitoring and watching the secure space to changes of state in the world is the solution.
Yeah. So yeah, I definitely agree with that. I sort of echo it. I think to some extent it depends on the context of the entry point. As you mentioned, download it onto your laptop. I think there's a lot of different places that you might pull it in, your laptop, your production system, whatever. And so I think as Yoav put it, if you can control the entry point of things entering your organization by sort of centralizing that stuff through a tightly controlled artifact storage system and sort of disallow fetching things directly from Docker Hub or wherever, I think that enables you to really now have a very controlled entry point to what gets onto developers' laptops or gets into production systems, because it becomes an interesting policy problem, right? There's a lot of different tools you could use, right? I might be running npm to pull down npm packages. I might be running Docker to pull down Docker packages. And so if you can sort of centralize how folks are allowed to pull in artifacts on their laptops by, centralizing that on a centralized artifact store, then it's really the mirroring process that becomes your entry point, right? And you can create policies when you sort of take things into that, and then it becomes less of a wild west of trying to enforce this across all of the different contexts on developer machines, because at this point it's very regular, right? They all have to come from that centralized system, and you can do stuff like sort of like OIDC federation at this point, right? Where that intake process is a lot like the sort of federation, right? You can evaluate policy from the sort of public signing, and then as you mirror it, you can sign it against your own root of trust. And now on developer machines, you can verify against your corporate root of trust that only your mirroring process, or your own developers producing internal packages, can potentially sign against. And now it's a much easier policy problem on developers' workstations or runtime systems, right? Because it has to be signed against your corporate root of trust, not figuring out who is allowed to publish various things against the public Fulcio or the public Sigstore root of trust, if that makes sense. And so you could do it on developer workstations, but I think it's a much easier problem, especially in really big shops, to try and centralize the management of some of that stuff.
Okay,
I
cool.
fully agree with what Matt
ahead,
was
Yoav.
saying. And by the way, once public repositories start to add these signatures, and I think NPM started, right?
They're working on it. I think there's some changes are needed to NPM itself. There may be an RFC for it, but I'm not sure what the latest is on it.
But we will add the same in Artifactory. So once you proxy in a remote library from a repository that has Sigstore signatures, we will verify against the public system of record that those artifacts are signed before caching them in.
Cool. No, I think that kind of captures how things get into an ecosystem. And I think we've been interchangeably talking about binaries, packages, libraries, different types of artifacts which come into a system. And just to kind of level set with the audience, what type of artifacts do you want to do security scanning against? Do you want to have identity and like authorization against? Like what's the range of incoming things which you want to secure?
For me, everything.
Yeah.
Go ahead, man.
Yeah, I was going to say, absolutely, Yoav's right. Everything. I think, to the point I was making before about like, even just looking at container images, historically, right? The number of pieces of information you have to extract from those historically before you had sort of SBOMs to try and capture the breadth of the information stored across those things was, made it hard to just do it for containers because there's so many sources of that information. And once you start talking about N artifact shapes, it explodes, right? But if the shape of SBOMs, it really just becomes a subset of the information you'd have for the container, and it's otherwise very regular across those different contexts. I think your ability to run those scanners on the SBOM metadata becomes very, very powerful across every context where you might have a bill of materials for a particular artifact, right? There's nothing specific to containers about it. It's just, that happens to be one of the very popular forms of artifact, which is popular enough that folks have put in that effort today. But I think we will, as containers and the tooling around this stuff for containers starts to focus in on that sort of standard API that SBOMs form, and tooling starts to emerge for that SBOM. And the stuff that goes into containers increasingly publishes SBOMs. You should be able to use the tooling that you can run on container SBOMs at any point in that supply chain and get that information, hopefully throughout that entire life cycle, which is my hope to reach that, scan it everywhere, right?
Yeah.
Cool. Okay, so just kind of close things out. if you had to give kind of like one takeaway for developers looking at like how they would improve the supply chain security in their organization, what should they look at? Like what, give them like one thing they should research or investigate or consider for their technology stack or their DevOps pipeline.
Regardless of JFrog or not JFrog, they should be informed consumers of binaries. So whatever they take in, they have to know what they're getting into their house, into their homes. At the end of the day, what those terms are used interchangeably, like binaries, modules, packages. In JFrog, we set it on the term package version, which is very technical, but it defines exactly what we mean when we refer to a certain release. But at the end of the day, this is what's going to end up in your runtime. Everything that's in your code, fine. It's the ingredients. It's like the recipe for creating the blueberry pie. But at the end of the day, this what you pour into the blueberry pie is what's going to run, and you have to know what you're getting into your organization.
Yeah, I'm gonna riff on that for my own take on it. I would say I would start to look at introducing signing into your processes. I think part of that is, as you have put it, right, starting to become informed on this this topic, right? And I think one of the ways to become informed is to try and start to sign these things yourself. I think a great first thing to sign would be, besides the artifacts, would be the SBOMs for your system and looking at some of the tools there. But I think starting to introduce that, right? Signing is not the end goal. Signing is the beginning. It's a way of authenticating the metadata. And then once you've figured out how to sign stuff, you can then start to sign not just artifacts, but SBOMs, things like attestations about these pieces of information. And it's really the beginning. It's not the end goal. And so finding ways to incorporate signing of things into your processes, I think will enable you to then start to layer on more and more sophisticated information. And as Yoav put it, right, as more folks start to sign things, you will be in a position where I think you are informed about the ways these things work so that you are more prepared to consume signed metadata about these things and author your own policies around them. So I would say that.
Just to add one more thing to that, signing on top of scanning, because at the end of the day, you want to know if you have a 0-day, if you have a malicious package, if you have a CV, you want to be able to sign this added metadata. And for that, you need to scan the artifacts. You have to scan the binary and extract this additional information that is not necessarily evident from public sources.
Absolutely.
Cool. All right. Thanks so much, Matt, Yoav, for having an awesome session. I think we covered like a very deep topic in an approachable way for the audience. I want to thank all our folks who joined in for the webinar, and we'll also have this recording posted online later if folks missed it. So thanks again. Great job. And it was awesome having this conversation with both of you.
Yeah, thanks for having me.
Thanks. Take care.